Unit 3 is all about functions, and we're going to talk about a lot of different kinds of functions. We're going to talk about domain and range, but the very first thing that we're going to do is we're really going to tie the idea of absolute value, which is a type of function. We're going to tie it to solving equations like in Unit 1. Then in 3.2, we're going to talk about independent variables, which leads us right to the idea of what is a function. We're going to spend some time graphing functions and analyzing functions as well. So this first section is sort of its own little piece, all about what is absolute value and how do we solve equations that involve absolute value. So I want you to think about a car for a minute. If you're driving in a car, there's something called an odometer. And what the odometer in your car does is it measures how many miles your car has traveled. So if I'm going on a trip, it measures how far from my house to the destination that I get to. That number is always increasing because it's measuring how far the car has traveled. Now, if I put the car in reverse and I drive backwards, it doesn't take any miles off the distance because I'm still traveling a total number of distance, a total mileage of the car. And the key idea there is that distance is always positive. It doesn't matter if I'm traveling forward or backwards or diagonally, I'm still traveling. If you think about a smartwatch keeps track of the number of steps that you take. If you take 3 steps forward and 3 steps backwards, and then you look at your smartwatch, it would tell you that you took 6 steps. It wouldn't tell you that you took 0 steps. So this ties to the idea of absolute value because absolute value is talking about distance, and it's specifically talking about how far a number is from 0. So we're going to tie this to a number line, which makes us think about unit 2. We're going to tie it back to solving, which makes us think about unit 3. So the symbols that you're going to see for absolute value are 2 vertical lines, and they will surround something on the inside, some sort of function. 2 vertical lines. That's the symbol for absolute value. And when you first learned about absolute value, way back in probably middle school, you learned that a number's absolute value makes it positive. So if I was taking the absolute value of -6, that would give me +6. But you may not have really learned the reason that that's true. The reason that's true is because this is asking you how far is -6 from 0 on a number line, and how far is always going to give you a positive number. So that's why absolute value gives you a positive number. That's why when you have a number inside absolute value, your job is to make that number positive. So think for a minute about this question right over here. If we were being told to solve for the absolute value of x is equal to 5, that is really asking you what numbers are 5 units or 5 spaces away from 0 on the number line. So here's 0. I want to go 5 away from 0. But there's 2 directions to go away. There's up and there's down. So I could go 5 away from 0 this way. There are actually 2 numbers that are, in fact, 5 away from 0 on a number line. Those 2 solutions are -5 if I went 5 to the left on a number line, or +5 if I went 5 to the right on a number line. And the way we write this is using set notation, and we always write the smaller number and then the bigger number. And something I'm going to tell you right now is that that number is not always the same. It's not always going to be both the same number. So let's look at this next example. This says the absolute value of x minus 2 equals 4. So remember, absolute value means a number's distance. So this is saying the distance is 4. So we are 4 away from 0 on the number line. So let's look, here's 0, we're going 4 away. 4 away we could go up, or 4 away we could go down. And what is 4 away from 0 on a number line? The thing that's inside of absolute value. So that's x minus 2. And over here that's x minus 2. Well, what numbers are 4 away from 0 on a number line? Well, there's 2 of them. There's +4 and there's -4. So what we just did was we just created 2 different equations that are going to give us the values that will make x minus 2 4 spaces away from 0. So here we can just solve this like we did in Unit 1. I can add 2 on both sides here, and I can add 2 on both sides here. That's going to give me over here that x is negative 2, over here that x is 6. So I can go back up here and I can write my solution that x is going to equal negative 2 and positive 6. We were looking for values of x where x minus 2 was 4 units from 0. Go ahead and pause the video, see if you can figure out what's being asked. See if you can kind of use your number line to set up what's being asked. Go ahead and pause your video. So we are being asked what numbers make 2x plus 1 5 away from 0. So 2x plus 1 could either be 5 above 0 or 2x plus 1 could be 5 below 0. So what that means is that I really have two different things I'm looking at. I'm looking at what happens if 2x plus 1 is 5 below 0, which would make it negative 5. Or what happens if 2x plus 1 is 5 above 0, which would make it positive 5. And now I'm just going to solve these two equations. I'm going to subtract 1 on both sides. That's going to give me 2x equals negative 6. I'm going to divide by 2. That's going to give me x equals 3. I'm going to follow that same process in the other equation. I'm going to subtract 1 on both sides. That gives me 2x equals 4. I'm going to divide by 2. That gives me x equals 2. So my final answer, set notation, the smaller number than the larger number, just like with intervals. So negative 3 and positive 2 are both going to give me the right answers. Here's something that's cool about absolute value. We can actually check and make sure that our answers are right. So let's plug in negative 3. The absolute value of 2 times negative 3 plus 1. Well, 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. And the absolute value of negative 5 is 5. So we're right. Similarly, we could plug in 2. 2 times 2 is 4. 4 plus 1 is 5. The absolute value of 5 is still 5. So that's something that's really nice about these problems is at the end you can plug in your answers to make sure that those answers are actually correct. Why don't you pause the video and see if you can work through 1 and 2, and if you find those to be pretty straightforward, see if you can challenge yourself by looking at 3 and 4. Okay, number 1 is asking us what for values that are 7 away from 0. So thinking about a number line, that means that 3x could either be 7 above or 7 below 0. So that means that 3x could be negative 7 or 3x could be positive 7. If I divide both sides by 3, I'm going to get negative 7 over 3. If I divide both sides by 3 and the other one, I'm going to get positive 7 over 3. So that's going to give me x equals negative 7 over 3 and positive 7 over 3. Number 2, 4x plus 1 is 21 spaces away from 0 on a number line. So thinking that through, that means it could be 21 spaces below. So 4x plus 1 could be equal to negative 21. 4x plus 1 equals 21. Then we're going to solve each of those equations. We're going to subtract 1 from both sides in both equations, and then we're going to divide by 4. Remember to always simplify your fractions. I'm running out of space, so I'm going to come down here a little bit. So negative 22 over 4, if I divide both of those by 2, I get negative 11 over 2. So that's one value. The other value was just 5. So those are our two answers for number 2. Let's look at number 3. Number 3 says 3x plus 3 is 0 units away from 0. Let me say that again. 3x plus 3 is 0 units away from 0. What that means is it's not above 0 and it's not below 0. It has to be exactly 0. So how many equations are we going to be able to set up? We're only going to be able to set up one equation because it's exactly at 0. Then we're going to solve that one equation. That's going to give us 3x equals negative 3 if we subtract 3 on both sides. Then we're going to divide by 3 on both sides, and that's going to give us that x equals 1. So there's only going to be one solution because if it's equal to 0, then it's no spaces away. It can't be above or below. Now let's look at the last one over here. The absolute value of x equals negative 9. So let's think about what that's saying. A number's distance from 0 is negative 9. So if I looked at my smartwatch, would it ever tell me that I took negative 9 steps? No. So this is something really special that you need to watch out for. We can never have absolute value equal to a negative number. So if it says that, we're going to write no real solution. And you can write the empty set if you want, or you can just write no real solution. So absolute value, a number's distance from 0. Think about how many above and how many below to set up usually your two equations and solve. Watch out for if it's equal to 0, there's only going to be one equation. And if it's equal to a negative number, there aren't going to be any equations because that's just not possible. Something I want you to think about. I want you to think about the order of operations, and I want you to simplify this purple expression and simplify this blue expression and decide if they give you the same thing. So follow the order of operations and simplify them both. So in purple, according to the order of operations, I need to do what's inside first. So I'm going to add 7 and 3 to get 10. The absolute value of 10 is 10. Negative 5 times 10 is negative 50. Now let's simplify the blue. And if you notice, what is happening here is instead of multiplying the negative 5 at the very end, kind of like we distributed here, that's what it looks like is happening over here. That's what we're assessing. If I distribute this negative 5 into the absolute value, do I get the same thing? So that's what we're going to check. So let's see. This would give me the absolute value of negative 5 times 3, that's negative 15. Plus negative 5 times 7, that's negative 35. So that's going to give me the absolute value of negative 50, which is positive 50. So something I want you to notice, these are not the same. So to answer this question, no, they are not the same. And the thing I want you to take away from this is that you cannot distribute absolute value or a number into absolute value. It's not the same as distributing with parentheses. So please make sure you're not trying to distribute a number into absolute value. That's not something you're allowed to do. So let's recap what we just did on the problems above, 1 through 4, to solve those absolute value equations, and then let's add on a little tiny bit. So what do we do first? The very first thing you need to always do is you need to isolate, meaning get by itself, the absolute value. So before you start breaking it up into multiple equations, you need to have absolute value by itself on the left, all the stuff that's not inside the absolute value on the right. Also, just like we saw on example 4, you need to check to make sure that C is a positive number after you do that. If it's not a positive number, it's going to be no real solution. Step 2, think about your number line. How far from 0 above would that number be, and how far from 0 below would that number be? And that's going to give you your two equations, right? Your above equation and your below equation. And then third, you're going to solve each equation. Remember that you can check your answers by just plugging them back in. And also remember to write your final answer using set notation with the smaller number before the larger number. So for number 5, absolute value is not isolated. What is the thing that's preventing the absolute value from being by itself? It's this positive 8. So let's go ahead and subtract 8 on both sides. That's going to leave us with the absolute value of x plus 5 equals 4. Now we have a problem like we had on 1 through 4. Absolute value on the left equals everything else on the right. So this is saying the distance that x plus 5 is from 0 is 4, which means it could be 4 above, positive 4, or it could be 4 below, negative 4. So let's set up those two equations. X plus 5 equals negative 4, x plus 5 equals positive 4. We're going to subtract 5 on both sides. That's going to give us negative 9 and negative 1. And we're going to write our final answer in set notation, negative 9 and then negative 1. On number 6, there's two things preventing the absolute value from being by itself. The 2 and the negative 3. So we're going to deal with them by first adding 3 to both sides. So that's going to give me 2 times the absolute value of 2x plus 1 equals 16. And then we need to get rid of the 2 in front, so we're going to divide both sides by 2. That's going to give us the absolute value of 2x plus 1 equals 8. Now we can break it into two equations. Remember, you can't break it into two equations before you isolate the absolute value. So now we're saying 2x plus 1 is 8 spaces from 0, either 8 above or 8 below. So I can say that 2x plus 1 equals negative 8, meaning it's 8 below, or 2x plus 1 equals positive 8. We're going to subtract 1 on both sides, so 2x equals negative 9. Subtract 1, 2x equals 7. I'm going to come down here. Then divide by 2, so x is going to be equal to negative 9 over 2 and 7 over 2 for number 6. Okay, number 7, isolate the absolute value, so we're going to add 4 on both sides. So the absolute value of 4x plus 1 equals negative 17. So a number's distance from 0, 4x plus 1, the distance from 0 is negative 17. Wait, the distance is negative 17? That doesn't make sense. That's why I always talk through out loud what I'm saying here. Negative 16 cannot be the distance. That means there is no real solution, or you could type the empty set, the 2 set notations with nothing inside. All right, almost done. Number 8. First thing we need to do is add 9 to both sides. So the absolute value of 2x plus 3 equals 0. A number's distance from 0 is 0. A number's distance from 0 is 0. So we're only going to have one equation because there's no way to make 0 negative. I can't go above and below because I'm exactly at 0. I'm going to subtract 3 on both sides. I'm going to divide by 2. So x is going to equal negative 3 over 2. So let's wrap this up. Absolute value is a number's distance from 0. That distance could be above or below, but absolute value is never going to be negative. In fact, if it is negative, that means you have 0 or no real solutions. If that absolute value is equal to 0, like it was on number 8, you could have one solution. But in most of the problems that we did in this section, we had 2 solutions. Those are your only 3 options. So remember to always isolate your absolute value first, then split it up into 2 equations, making sure that it wasn't negative originally, because we can't have a negative distance. Solve those 2 equations and write your final answer using set notation. Don't forget that you can check your answers to make sure that they actually make sense and are correct. I hope you enjoyed this video, and I look forward to working with you in class.